So today's topic is on solving linear inequalities. A linear inequality is an inequality that contains an algebraic expression of degree 1. So that means the exponent, or the highest exponent on the expression, is 1. Most linear equations only have one solution. However, linear inequalities may have many solutions. In this first example, we're going to look at some rules for linear inequalities. So given the numbers -2 and 6, which inequality sign goes here? Less than or greater than? So we see that -2 is less than 6. What happens when you add or subtract both sides by a number? Let's say we add 4 to both sides of this inequality. We get -2 plus 4 less than 6 plus 4, which gives us 2 is less than 10. And we see that this inequality still holds true. What happens when you multiply and divide both sides by a positive number? Let's say we multiply both sides by the number 3. So we have -2 times 3 less than 6 times 3, and we see we get -6 less than 18. So once again, we notice that the inequality still holds true. Finally, let's look at what happens when you multiply or divide by a negative number. And for this final one, let's say we multiply by -3. So we get -2 times -3 is less than 6 times -3, and we end up with 6 less than -18. Here's the case where we see the inequality is not true. So for this example, we must reverse the inequality sign. And therefore, we should end up with 6 is greater than -18. So for examples where you multiply or divide both sides by a negative number, we are going to switch the inequality sign to keep the statement true. Now let's look at some linear inequalities. So for our second example, we're going to solve the linear inequality -4x plus 2 is less than or equal to 12. So what we're looking for is when is the line -4x plus 2, and that's this function right here, let's call it f of x, when is that less than or equal to 12, or if we like g of x. So when is the function -4x plus 2 less than the function 12? And if we look at the graph, we can see that the green line is lower than the blue line for this shaded region right here. So let's determine what this solution might be. So first off, we have -4x plus 2, and we want to determine when it's less than or equal to 12. We start by solving this just like an equality. So the first thing we're going to do is subtract 2 from both sides. So that gives me -4x is less than or equal to 10. So again, all I did was subtract 2 from both sides. And we're going to divide both sides by -4. And remember, since we're dividing by a negative, we need to switch the inequality sign. So we're going to get x is greater than or equal to -5 over 2, or -2.5, which if we go back to our graph, that is approximately where we see the intersection of the two lines. The solution in set notation is, and we say x is in the real, and x has to be greater than or equal to -5 over 2. Or using interval notation, we have the following. We have that x is in the square bracket -5 over 2, comma, infinity. Notice we put the square bracket here because we said greater than or equal to. So to include -5 over 2, we need the square bracket. If we did not want to include -5 over 2, we would use the rounded bracket. And finally, on a number line, that could be represented by the following. So we know -2.5 is where the two lines intersect, and all solutions greater than, or all x values greater than -2.5 are a solution to this inequality. Notice I circled in the -2.5 since it is included in our solution. Let's try example 3. All right, so first step, we're going to add 7 to both sides. And we end up with 3x is less than 12. Dividing both sides by 3 gives us that x is less than 4. And we can verify this from the graph. So again, here's f of x, that is our 3x minus 7. Here's g of x, that is 5. So when is the line less than 5? Well, we can see that solution right here. There's where the line is below the blue line. And we see that happens when x is less than 4. So at x equals 4 is where the two lines meet, but the solution for where f of x is less than g of x, or where 3x minus 7 is less than 5, is when x is less than 4. So let's write out our answers. So again, using set notation, we get the following. And using interval notation, we get. Notice this time the 4 has a rounded bracket since we're not going to include the x value of 4 for our solution. So using a number line, we see that x must be less than 4. So we leave an open dot at 4 since we do not want to include 4. And there is our solution using a number line. Finally, let's take a look at a double inequality. And the best way to solve these is to do everything from the middle. So for example, I have 2x minus 1. So the first thing I want to do to isolate for x is add 1 to all sides of the inequality. So I end up with negative 4 is less than or equal to 2x is less than or equal to 6. And same as solving other inequalities, we're now going to divide all sides by 2. And I'm left with negative 2 is less than or equal to x is less than 3. And we can see this graphically once again. So this one is saying, when is 2x minus 1 in between negative 5 and 5? So here is the line, and we can see it's above negative 5 and less than negative 5 from negative 2 all the way up to 3, highlighted there in green. So let's conclude. So the solution in set notation is the following. Or we can represent the solution in interval notation. Again, notice the square bracket on the negative 2 and the rounded bracket on 3. Finally, if we needed to express the solution in a number line, we would start at negative 2 and have a solid dot. At 3, we would have an open dot, and we would connect those two dots. And there is our solution for this inequality.